Good morning. Cryptococcal disease causes 15% of AIDS-related deaths. As you can see from this map, the majority of cases occur in sub-Saharan Africa, where mortality is 50 to 70%. Mortality is so high due to delays in presentation to care, the need for complex management such as serial lumbar punctures, and difficulties in accessing optimal antifungal medications. As a result, there are an estimated 136,000 deaths annually. However, cryptococcal meningitis can be prevented. Cryptococcal antigen can be detected in the blood before onset of meningitis, and preemptively treating those who are asymptomatic but CrAg positive with fluconazole is life-saving. This has been most rigorously evaluated in the REMSTART trial in Tanzania and Zambia, where alongside adherence counseling, cryptococcal antigen screening and treatment resulted in a 28% survival benefit. As a result, CrAg screening and preemptive treatment is now recommended by the WHO and numerous national HIV programs. The objective of our study was to evaluate the costs and lives saved of a Ugandan national CrAg screening program for people with a CD4 count under 100 per WHO guidelines. We also extended this analysis to a universal CrAg screening program in an HIV test and treat scenario where no CD4 testing occurs. For our base case model, we assumed 1 million people get CD4 tested, 16% have a CD4 count under 100, and we assumed 80% of these people who are eligible for CrAg screening would actually get tested. We assumed that 80% of those who are tested actually return for results. This 80% is simply an estimate just to account for an imperfect screening program. We assume that 8% of people with a CD4 count under 100 were asymptomatic and CrAg positive, and this is taken from prospective cohort studies in Uganda. If a person was found to be asymptomatic and CrAg positive, we assume that only 80% of them receive treatment. Again, this is so that we have a conservative estimate, and we're assuming an imperfect screening program. And then we made survival estimates based on prospective studies from Uganda and sub-Saharan Africa, with and without treatment. If a person was found to have cryptococcal meningitis, we assumed 80% were hospitalized, and we estimated survival in the hospital and then 6-month survival based on large randomized control trial and prospective cohort studies from sub-Saharan Africa. Input costs are seen here. On the left, you can see some basic CrAg screening costs. The test itself, the CrAg lateral flow assay, was assumed to cost $3.41, including shipping and lab overhead costs and labor. The course of fluconazole used to treat asymptomatic CrAg positive people was estimated to cost $39 US. On the right, you can see the cost of treatment for meningitis. We assumed that everyone would be hospitalized for 14 days, so there were room and board costs. Everyone was assumed to be treated with amphotericin and fluconazole for 14 days, which is standard of care in our setting. People receive lab testing because they're receiving amphotericin, so electrolyte monitoring and creatinine testing. We included the cost of hospital personnel, doctors and nurses. Everyone was assumed to receive 1 diagnostic lumbar puncture and 2 therapeutic lumbar punctures, and there were some miscellaneous hospital supplies. So the total hospitalization cost for meningitis treatment was $563. So in the base case model where people got CrAg screened if they had a CD4 count under 100, in the scenario where no CrAg screening occurred, we estimated 4,272 deaths from cryptococcal meningitis. There was no cost to screen and treat because no screening was occurring, and the cost of meningitis care in the hospital was $3.7 million. So total costs, including outside of the hospital, was about $4 million US. In the scenario of a CrAg screening program, we estimated 2,755 deaths from meningitis. The cost of the screening and treatment piece of it was $731,000. The cost of meningitis care for this group was $2.4 million. So the total cost of the CrAg screening program was $3.3 million. So when you compare CrAg screening to no CrAg screening averts over 1,500 deaths related to cryptococcal meningitis and saves $700,000 of costs, saving $453 per death averted. And just to clarify, typically when we use the term cost effective, it means we're using money to save lives. But what I'm saying here is with the CrAg screening program, the Ministry of Health would actually save $453 per death averted. Another way of looking at these results is in this graph form. Across the x-axis, you have proportion CrAg screened and treated. On the left side, you have 0% CrAg screened and treated, and as you move to the right, you have increasing proportion screened and treated. On the left y-axis, you have cost in US dollars, and on the right-sided y-axis, you have deaths. As you move from the left, which is no CrAg screening, to the right, which is full implementation of CrAg screening, you can see that the bars are reducing in size, and the bars represent cost here. And the main change from the left to the right is the green part of the bar, which is going down, and that is the cost of hospitalization. The horizontal blue line represents deaths. So as you move from left, which is no CrAg screening, to full implementation of CrAg screening, you're also reducing deaths. With perfect implementation of CrAg screening, meaning 100% of eligible people are screened and treated, we estimate you could save 1,900 lives and save $860,000. Now moving on to the universal CrAg screening program within an HIV test and treat scenario, we're assuming no CD4 count is conducted and everyone who enters HIV care is eligible for CrAg screening. Here we assumed 1 million people entered care, 80% had a CrAg test conducted, 80% of those people returned for results, and the CrAg prevalence, so the proportion who are asymptomatic and CrAg positive, was 1.4%. With no CrAg screening, we estimated 3,800 deaths from cryptococcal meningitis. There was no cost to screen and treat. The cost of meningitis care was $2.89 million, and the overall cost was about $3 million. With CrAg screening, we estimated 2,180 deaths. The cost to screen and treat is significant at $2.18 million. The cost of meningitis care was $1.5 million, and the total cost was $4.1 million. So here we find when we compare CrAg screening to no screening, CrAg screening averts 43% of deaths related to cryptococcal meningitis at a cost of $1.08 million. So in this scenario, it would cost $662 per death averted. I can show you these results in a similar graph where across the x-axis you have proportion screened and treated. And you can see that the costs, which is represented in the bar part of the graph, go up as you move from the left, which is no screening, to the right, which is full implementation of CrAg screening. And as you move from left to right, the blue part of the bar graph, which represents the cost of actual screening, goes up significantly. And the reason for this is you're screening a much larger population with a very low prevalence of CrAg positivity. You can see the blue horizontal line that goes across is going down, meaning there are less deaths as you go from no screening to full screening. With a perfect implementation of this program, one could expect to save 2,033 lives at a cost of $1.3 million. So in conclusion, a national CrAg screening program in the setting of CD4 testing and CrAg screening for those with the CD4 count under 100 is likely to be cost-saving and life-saving. Availability of hospital care, hospital costs, and the treatment regimen for meningitis is integral to the cost-effectiveness of a national CrAg screening program. Universal CrAg screening in an HIV test and treat environment is likely to be cost-effective based on the overall CrAg prevalence of 1.4%. Here, CrAg screening all HIV-infected people averted 43% of deaths from cryptococcal meningitis at a cost of $662 per death averted. I'd like to acknowledge all of our collaborators, Bruce Larson, who is my primary mentor for this project, our colleagues at the Infectious Disease Institute, CDC, and the Ugandan Ministry of Health. Thank you.